So this is my handwritten and handmade diagram and chart to explain the optical radiation, the 7 wavebands of optical radiation lying between the microwaves and X-rays. Electromagnetic wave spectrum, it ranges from the radio waves to cosmic rays, X-rays, gamma rays and all. So here you will see these radio waves, then microwaves, and then this is the optical radiation between the microwaves and X-rays, and after that there is what X-rays, gamma rays and cosmic rays. Microwaves, here there are radio waves. So these are the 7 wave bands. This is the visible radiation. On the left hand side you will see this is the infrared region. On the right hand side you will see the ultraviolet range. On the right hand side, on the left hand side you will see the longer wavelengths, and on the left hand side you will see the shorter wavelength. Shorter wavelength means higher energy. So you will see the optical radiation lying between the microwaves and X-rays, that is infrared C, B, A, then visible radiation, then ultraviolet A, B and C. So how to remember where the A lies? Visible radiation, adjacent to the visible radiations lie in infrared A and ultraviolet A region. So AA, then BC, then BC, like that you remember. So infrared C, you remember these numbers: 10,000, 3,000, 1400, 780, 400, 315, 280 and 200. So you can remember the range of these 7 wavebands. So infrared C, 3000 to 10,000, you can say 10,000 to 3000. Then infrared B, 3000 to 1400 nanometer. Infrared A, 1400 to 280 nanometer, 780 nanometer, 1400 nanometer to 780 nanometer. Visible radiation falling between the 780 nanometer to 400 nanometer. Then ultraviolet A falling between the 400 to 315 nanometer. Then ultraviolet B between the 315 to 280 nanometer, and ultraviolet C between 280 to 200 nanometer. So you remember all these things. And what is the significance, why we should remember all these things? So infrared C and infrared B, these are absorbed by the cornea and the sclera. These are the longer wavelengths. Also the cornea and sclera, they absorb the shorter wavelengths. These are ultraviolet B and ultraviolet C. These are absorbed by the cornea and the sclera, which are these 3000 to 10,000, 1400 to 3000 nanometer, infrared C and infrared B respectively. And these are the longer wavelengths, and shorter wavelengths, ultraviolet B and ultraviolet C between 280 to 315, that is UVB, and 200 to 280 nanometer, UVC. These are absorbed by the cornea and the lens. And this region, these rays, ultraviolet A rays falling between 400 to 315 nanometer, these are absorbed by the crystalline or natural crystalline lens. And what is the clinical significance of this is, when the natural lens is taken out and we implant the intraocular lens that doesn't have the UV filters, or if the patient is left aphakic, then the patient complains that the patient is seeing everything bluer than before the surgery. So it is because these ultraviolet A rays, these blue rays, are falling on the retina, stimulating the retinal photoreceptor, and that's why, which doesn't occur normally because of this crystalline lens. It absorbs these kind of wavelengths, so we don't see that kind of blueness which these aphakics and pseudophakics without with IOL without UV filters, they see everything bluer than before. So that's a complaint, and that's why it's very important to implant the intraocular lenses with UV filters, because these are very damaging to the retina. Now that was about the UVA, and this infrared A region, that is 1400 nanometer to 780 nanometer, to visible radiation, that is 780 nanometer to 400 nanometer. They pass to the ocular media, fall onto the retina, stimulate the photoreceptors, and they give the sensation of the light. These visible radiations and these infrared A, they fall onto the retina and they have the thermal effect. They can damage on the retina if their intensity is high, and if the exposure is for a longer time, for example eclipse burns, because this during eclipse time, the infrared rays, they fall in this region, they fall onto the retina, and if we see it with the naked eye, then we can burn our retina, that is eclipse burns. So that is the clinical significance of these wavebands. Now in short, color vision test, what kind of color vision tests we saw? Ishihara, Farnsworth Munsell test, MUNSELL test, FM100 hue test, then D15 test, Lanthony new color test that is used in children, Holmgren's wool test, lantern test, City University test, Nagel's anomaloscope test. I don't know the pronunciation. I call it Nagel anomaloscope test, Hardy Rand Ritter test. So these are the color vision test. Once again, what we learned in color vision test. Actually, we learned only 4. That is Ishihara, Farnsworth, Munsell, FM100 hue test, D15, and Lanthony new test in first chapter of Elkington's. I have added these few tests. I have added these other tests here: Holmgren's wool test, lantern test, City University test, Nagel's anomaloscope test, and Hardy Rand Ritter test. So enough for today. So hope you have understood this. Thank you so much for listening to me patiently. Bye.